So my name is Kiran Kumar Shah. I'm currently heading AML Safety Department in Kumari Bank Limited. So today topic is about application of machine learning in transaction monitoring. Data science and machine learning are both hype word, and many people have a lot of misconception about this term. So my objective for this presentation is to clarify these terms, and also in this presentation I will start with some theoretical background of data, what is data science and what is machine learning is all about. Then I will go to the practical aspect of machine learning, where I will be showing you application of some machine learning algorithm in transaction monitoring area. So my objective here is how machine learning can help you in in the transaction monitoring area. And after that, I will also give short introduction to data analysis visualization tool that is called Tableau. And I think it will be useful. I think the compliance managers or those who are involved in AML safety professionals will find this tool very useful. So let's start with our presentation. So I think it is important that we clarify some terms. Okay, so see, the computer science is like, it covers everything from artificial intelligence, from network, security, database system, computer interaction. So basically everything about computer is covered in computer science. And then we come towards data science. So data science is a study of data. It combines multiple fields like statistics, scientific methods, artificial intelligence, data analysis. So data science main objective is to extract valuable information from the data. Artificial intelligence. So artificial intelligence is a subset of data science. It deals with building smart machines, and which is able to perform tasks that typically require human intelligence. For example, email spam filters, Netflix recommendation, Siri, Alexa are example of artificial intelligence. So machine learning, we'll go into the great detail about machine learning in this presentation. But for now, the machine learning is a mathematical way of copying human ability to learn over time through a new experience. So I will talk about this also in later slides. And data mining, again, data mining is subset of machine learning. So data mining is the process of uncovering patterns or other valuable information from the large data set using machine learning algorithm. So these concepts are usually used interchangeably. But however, there is a big difference between these terms. So let's talk about machine learning, because our topic today is about machine learning. So let's start with a small history of machine learning, how it was started. So in 1959, IBM published a paper in IBM Journal of Research and Development, authored by Arthur Samuel. So he was the first person who coined the word machine learning. So what he did was, he taught a machine to play the game of checker, and the machine became better at playing game of checker than the human being. So how it was possible? How it became possible was, the machine actually recorded the piece of checker, right, and its potential move. Then it assigned the possibility of winning score for each potential move. And as the author played a lot of games of checker with the machine became more familiar with the game, and it improved itself by understanding how not to lose in that game. So machine learning is nothing. So main engine behind machine learning is a statistical model, and I think some mathematical model that you have also heard is the regression model that I think we studied at intermediate level. So machine learning uses this kind of statistical models. And so machine learning is different from programming, because in programming, programmer usually provide instruction. He writes an instruction or a program, and program, it generates output, and that output is predictable. But in machine learning, programmer doesn't give any instruction to the machine, and the machine itself has to identify different patterns in the data, and eventually it will perform the prediction on the basis of those identified pattern. So this is the overall concept of machine learning. Now we will move to the types of machine learning. So first one is supervised learning. So there are three types of machine learning, and we are covering the first type of machine learning, that is supervised learning. So in supervised machine learning, data set is labeled, meaning that you know the both input features and output. So let's say in this example, you are given a task to predict the car price based on the different features of the car. So first feature is year of make, second is your car brand, and third one is your mileage. So these are all historical figures, and on the basis of these historical figures, you need to create a model which can predict the price of the car accurately. So you are also given the car price. Now the accuracy or performance of model is measured against how accurately it can predict the actual price of the car. So if the model is predicting the actual price of car, right, so that model is performing well. If not, then the model needs to be adjusted. And again, in supervised learning, you are given both input features and output features also. Unsupervised learning. So it is different from supervised learning in the sense that output is not clear, or output is not given to model. So it is upon machine learning algorithm to identify what will be the output. So in the figure, this figure is using k-means algorithm. It is a popular unsupervised learning, where it is in this figure, this algorithm is grouping customer based on the similar characteristic of that customer. It may be their purchasing behavior or time of purchase. So on the basis of different characteristic of the or buying pattern of the customer, this algorithm is grouping this customer into separate groups. So this is about the unsupervised learning. And unsupervised learning is used in fraud classification, or credit card fraud classification, and machine learning, money laundering identification. So this type of algorithm is used in that kind of application. So reinforcement learning. The best example I can give about reinforcement learning is it's like playing a game. I think you must have played this game Mario, right? So in Mario, in Mario you become better at this game, right? By moving forward and not dying, right? So as you become more familiar with the game, you will understand different ways of not dying, and that's how you beat this game. And in the similarly, as you can see in the picture, so if this robot, right? So robot or agent, if he touches fire, he loses a point. Let's say 50 points he is losing whenever he touches the fire. But if he moves toward the bucket, then he will receive a positive score, maybe plus 50 points. So eventually, during this learning process, the agent or robot will understand not avoid fire and to take bucket and extinguish that fire. So in reinforcement learning, the data scientists will provide continuous feedback to the algorithm. So if the algorithm is doing positive things, then it is performing well. But if it is not performing well, then the negative feedback is given by the data scientist to the algorithm, and on the basis of that, the algorithm will adjust itself. And that's why the reinforcement learning is also known as continuous learning process. And as the machine continuously learning, it improves itself. And reinforcement is learning is used in driverless car, and and also in different kind of video games. In gaming industry, also the reinforcement learning is used. So this was just only the brief background of machine learning. So now we are moving towards the core concept of our presentation. So we are talking about transaction monitoring. As you all know that transaction monitoring is a important pillar of money laundering. The first one is KYC, second one is transaction monitoring. And I think most of organization today is using rule-based transaction monitoring, right? So usually in rule-based transaction monitoring, there are actually 5 steps of creating any kind of scenario or rules to monitor transaction and identify red flags. So first one is, let's say on the FATF typology or indicators or guidelines provided by different regulatory bodies, organization or bank or financial institution identify different type of money laundering transaction. For example, let's say Nepal FIU says that the different person who are given dollar cards, different customers who are being provided with dollar cards by the bank and financial institution, they are using that dollar card to buy crypto. Okay, so this is a trend they have that was actually identified by FIU Nepal, and it was communicated to banking and financial institution. Now, so in the second step, the banking institution will investigate if such kind of possible money laundering exists in their organization or not. They will search their databases or previous STR file, so to identify if such kind of transaction exists or not. Now let's say they found such kind of transaction, right? In third stage, they will identify if such transaction exists or not. And for example, let's say any bank found out that some customer were actually, and these customer were were students on the base according to their nature. So these were the students, and some were the unemployed. And what they were doing was that they were depositing a small amount of money, let's say $20, to digital wallet like Skrill or PayPal on a monthly basis, right? And when the inquiry was made to them, and they didn't give any reasonable explanation. So on the basis of that, bank assumed, or they became suspicious that maybe these customers were doing or using or loading their money in PayPal or Skrill or other digital wallets, and from there they were doing some kind of crypto transaction. So this is the third step, right? In third step, they analyze this kind of results. In the fourth stage, they will create a specific typologies. So in what does that mean is they will identify certain features of that transaction. So in our example, now the bank and financial institution have identified that the customers who are doing this kind of transaction are usually unemployed or student who have a low income group, right? And they are also dealing with only low currency amount, that is just above $20 or about $20. And another feature is they are depositing that kind of money to digital wallets on a monthly basis. So, and in the final stage, what the banking and financial institution will do is they will create a scenario on the basis of those feature of transaction. So the scenario for our example will be a generate alert if any customers who belong to low income group, like student or unemployed, who are depositing $20 or more in a digital wallet on a monthly basis. So in this way, any kind of scenario for monitoring transaction is created. So this is a widely accepted procedure. So there is a problem with this kind of rule-based transaction monitoring. So the first problem is this kind of rule-based transaction monitoring cannot detect money laundering scheme that uses less amount. If we talk about 9/11, 9/11, the total cost of carrying out that 9/11 scheme was about $100,000, only that much. And so after that incident, there was an investigation, and during that investigation, it was found that many wire transfer were made from Pakistan and also from UAE. So this transfer amount were very less amount, and this amount were transferred in the name of the terrorists who had opened the bank account in different banking and financial institution in USA. But these transactions were never caught by the bank, because bank has assumed, or we also assume, that money laundering usually happens in a big amount. So it doesn't happen in a small amount. So it is actually case of terrorist financing, but you can, but the transaction monitoring will not identify small amounts. And another problem with transaction monitoring is it generates lots of false positive, and it takes a lot of time and effort of our staff to investigate those false positive, and so that is a problem with transaction monitoring. And the third one is it is unable to detect new money laundering pattern. So after COVID, the many criminals have moved to virtual, moved towards the virtual. So most of the criminal transactions are done being online, and you can also verify this with the fact of rising different kind of scams, right, which are done through online. So now those rules which we have created that could only capture some transaction based on the cash threshold, so it is now useless. We need to revise those. So we need to revise those rules in transaction monitoring. So that is the problem with transaction monitoring. We need to continuously update those rules. First, we need to identify any kind of new money laundering trend happening, and on the basis of that, we need to revise those rules in transaction monitoring. And this is very difficult if we don't have that information about the new money laundering pattern. And the fourth one is scenarios are not itself. So the FATF and other guidelines, international guidelines, have suggested that the bank should develop scenarios to cover all the transaction of the customer, and customer can do transaction through different medium. They can do cash, they can do the transaction using cash, account transfer, IPS, mobile banking, card, right, QR. So there are different medium to perform a transaction, and it is very difficult to create all those scenarios to capture all type of transaction. And again, if we try to create all those scenarios, we will be generating lots of alerts. So it is kind of an impossible task to create a scenario for each type of transaction. So this disadvantage can be overcome by using machine learning. So the advantages of machine learning are it detects complex money laundering scheme. Machine learning has a different algorithms, right? So on the basis of those algorithms, it is very easy to identify different types of money laundering scheme. And another advantage is it can learn and adapt. So it is like a human brain. So as the more data comes in, it will understand those data and learn different kind of patterns, hidden patterns from that data. And on the basis of that, it can make prediction whether this transaction is money laundering or not money laundering. Then another advantage is scalability. So it can take, so machine learning algorithm can take a lot of data, okay, huge amount of data, big data. Even for analyzing big data, we use the help of machine learning algorithm. So this is scalable, and that is the main problem with rule-based transaction monitoring. So whenever you add more scenarios to that rule-based transaction monitoring, the system slows down. It cannot handle those kind of data, and excuse me, and this is the problem we are facing nowadays. So more rules we add to our AML solution, there is some kind of a performance lag. Then fourth one is reduce cost. So how machine learning helps in reducing cost is the main advantage of machine learning is it reduces the false positive, right? And when we reduce the false positive, our man hour and man hour time is both saved. So in this way, machine learning can help in reducing cost of any organization. I'm going to show you the example of machine learning algorithm, and I will walk you through this. So I have created a two machine algorithm to analyze a certain money laundering data, and I'm using Google Colab. So if you have access to Gmail account, you can easily have access to Google Colab. And the advantages of Google Colab is it is totally free, right? If you have a Gmail account, you can have access to Google Colab absolutely free. And another advantage is while running, you can easily just plug and play your algorithm. So just copy paste your algorithm and you can test in Google Colab. But if you have to install a separate software to test your algorithm, it will take a huge amount of resources. So the more data you have, it will take more resources. And Google Colab is a cloud-based solution, and that is why it has an advantage over any software that you install in your computer. So without further ado, let's start. So I will not make this complicated, right? So I will not go into that detail. I'll just help you to understand how machine learning can help you in analyzing your, or can be helpful in your transaction monitoring. So we'll import different libraries, right? So now let's look at this data. So this is the data, right? This is the data where we are going to identify which transactions are money laundering or which are not. So this since usually I had a very trouble in finding this kind of data, and I actually took this data from Kaggle website. So the Kaggle is a website where you can where you can get data of every sort. Let me just show you. Okay, so this is the data, right? So you can see the size of the data here. It's a 493 MB, and this data is actually simulated. So it is generated by system. So it is not data that is from any financial institution. And you can also, there is a separate research paper about this data. So there is a research paper, right? So this is the paper written by 2 authors, and this data is actually simulated data of customers doing wallet transaction in any digital wallet company, right? So the type, so these are the type of transaction they are doing. So payment, transfer, cash in, cash out. So these are the amount of transaction, and this is the originate wallet number, and this is the old balance in that wallet and new balance in the origin wallet, and this is the destination, let's say, wallet number, right? And this is the old balance of that destination wallet, new balance of destination wallet, and this it is the is fraud is the is fraud means here the sum data is 1 or 0. This means that for the transaction which where the is fraud level is 0, it means that it is not money laundering transaction. While where there is 1 flag, that means this transaction is a fraud transaction. So we are given this data set where it is already labeled which one is fraud and which one is not fraud. So for this type of data set, we are going to use supervised machine learning that we just explained earlier. So this is all about the data, and there are some assumption about data. So the reason why this transaction may be flagged as a money laundering transaction, the reason may be that most of the many originator are doing or transferring different amount to a particular or single destination account, or or one destination account is having lots of cash transaction, or one destination is doing large volume of transaction. So these are the assumption. Okay, so assumption on the basis of which these transactions are flagged as a money laundering or not money laundering. And let's say in this data, the maximum amount of transaction is about 9 crores, while minimum amount is only 0. Now this I want to clarify. As you can see, there are like 6 crore. I think this is 63 million. So 63 million transactions. There are total number of transactions is around 63 million. And out of which there is only 8,213 are fraud transaction. So it comes about 0.12%. Okay, so it is not even 1% or a half of percentage, while the percentage of non-money laundering transaction is almost 99.87. So in machine learning, we call this kind of data as a imbalanced data set. Why? Because you can see that the fraud transaction or money laundering transaction is only few. Okay, and when we make a model out of this data set, the model will not perform as per our expectation. The results can be skewed, meaning that it will predict all of the data as a not money laundering transaction. So I will tell you how we can fix this imbalanced data set later on. So let's look at some data visualization. We'll find if there are any missing data or not. So as we can see from the figure, there are it's completely blank, meaning there are no any missing data values in the data set. So let's look at the different types of transaction. So we have actually 5 types of transaction, right? And we're gonna now we are going to find the relationship between the type of transaction with the fraud. And you can see that there is a small amount of fraud transaction for these 2 types of transaction, transfer and cash out. you can see by this small yellow figure, right? So fraud is a yellow color. So for in transfer transaction and cash out transaction, there are small, there are usually the fraud transaction. For other types of transaction, there are no money laundering transaction. So I will be using term fraud and money laundering interchangeably. So please don't confuse on that. Okay, so this one is a kernel density plot. And again, I will not go into detail. So in a simple term, kernel density is used for visualizing the probability density of a continuous variable. So from the figure, so these two LEs, it is using LE7 in axis. So 2 LE7 is actually 2 crore. Okay, so it's a scientific notation. You can see from the figure, the red one is actually showing the money laundering transaction. So from the figure, you can safely assume that the money laundering transaction amount is about 1 crore, maybe 1 crore. So not above that. So we have a maximum transaction of 9 crore, right? So money laundering transactions are happening from 0 to 1 crore only, not above that. This is a correlation plot, right? We are looking here. We are drawing this correlation matrix figure to identify if there is any relationship between these variables. So we can see from this figure that there is no correlation. Yeah, there is a correlation between new balance and old balance, but that is not useful to us. We are looking if this is this variable have correlation with is fraud or money laundering transaction. So we are not seeing that. And the another problem with this data set is that it has very few features. Okay, so it has only amount or so it has only amount, old balance, new balance. But if you look at the FATF guideline on new payment methods, so or this one guidance, prepaid cards, mobile payments, and internet-based payment services. So the FATF have identified different red flags for mobile wallet transaction, and it would be much better if you could have a more features. If we could have a more information regarding like IP address of initiating of that transaction or IP address of the destination account, the country from which the transaction started and the transaction end, and also the information about the KYC status of the customer, then we could have made a more better model out of this data set. And in the machine learning, it is said that if you have at least more than 10 features, then you can make a better model. And as you can see from here, in this data set, we don't have those features, right? We only have few 5 or 7 features, and that is itself not sufficient to make a good model out of this data set. Anyway, but for the sake of example and clarifying some concept, we are using this data set. So now this is again I'll just talk about briefly about some technical aspect here. So we need to process this data. So as I've already said, that we have the amount figures, right? It is the minimum is 0.0 and maximum is 9 crores. And for all the for other data set also, we have a different values, right? And we cannot use these values directly to create a model. So we need to normalize these values. And to normalize this value, we use standard scalar. So it is a function in a machine learning. So we have to use that standard scaler to normalize and standardize those data. And then we need to apply also one hot code encoding. See, the model will only take numerical figure, but as we can see from the data set, this type has a characters, right? This is not numerical format. So we need to convert these 5 categories of transaction into numerical figures. So for that, we have to use one hot code encoding. Again, the concept may be sound alien to you. I can understand that. So you can, study by yourself. What does these terms means, right? In your own time. So just for understand, just for sake of understanding, kindly understand the one hot code encoding is used to convert string data into numerical one. So again, we are using correlation again, and after we have made some processing, we are not finding clearer correlation, right? Now this is the fun part. We are going to create our machine learning model. So we have to there are some procedure that we need to follow, and I don't think that it is necessary to discuss them. So the interesting part is here. So we are going to create two models: decision trees model and random forest classifier. These are both machine learning algorithm. So before we go into the model, I need to explain about the concept of these two models. So first one is decision tree. So decision tree is a type of supervised learning. Since the data set is a supervised, since the data is labeled, right? So we need to use supervised learning here. So it is a type of decision tree is a type of a supervised learning, and it is used for fraud classification and customer classification. So it is mainly used for classification task, right? And it predicts output based on certain simple decision rules and condition. So decision rules and condition are the questions. Decision rules simply means the different questions that are based on the analysis of data. So for example, in this figure, we are trying to identify from the pool of candidates whom to call for interview. So there are some criteria for deciding that. So first we are going to ask the question: does that candidate has a college degree or not? Right? If he has a college degree, then what kind of degree he has? If he has a master, then we are going to call him for interview. But if he doesn't have a master qualification, then we are going to look at his experience. So if he has like 3 to 5 experience, then we are going to call him for an interview. But if he doesn't have, then we are not going to give him a chance, right? So these are these questions, right? This question about experience and qualification are decision rules, and these decision rules are identified by algorithm based on the analysis of data. So the algorithm will on the basis of those analysis will identify which question to ask and to classify that data. So the same concept is applied here. So first we are going to extract the model, and we'll train that model on our training data, right? And on the basis of training, we are going to predict that data or predict the output. So this is the and then after that we are analyzing. We are going to analyze the performance of that data. So performance of that model. So as you can see, the different metrics here, so this is the precision, recall, and F1 score. And again, it is better to explain, clarify these terms. So precision means how accurate the model is predicting money laundering transaction out of total transaction. So that is precision. So precision means how model is predicting the actual money laundering transaction out of total transaction. And the problem with the precision is that it is ignoring false negative, right? The false negative is actually true positive. So it is the false negative are the actual money laundering transaction which is not catched by that model. Now, the recall is a better option than it is a better measure than precision because it covers that false negative. So it measures how accurate the model is predicting money laundering transaction out of total actual money laundering transaction. And F1 score is just a average of precision and recall. So as you can see, it is the model is model has a precision of 89% and recall of 89%. So the F1 score is 89%, right? Now, as I told earlier, this is an imbalanced data set, right? Meaning that there is money laundering, number of money laundering transaction is very few. So we need to make this data set balance. So we will be using SMOT. So it's a function of a machine learning. So which will increase the number of money laundering transaction synthetically in that data set. So here you can see after performing this function, we have the number of money laundering transaction has increased to 127. So the previously our data set was like 6 million, I think. So 63 million. Now it is like 127. So it has just doubled that data set by increasing the number of money laundering transactions. So now the data set has been balanced, right? So let's use our model on this revised data set and measure its performance. So after doing SMOT, we can review the performance measure, and we can find that the precision has increased to 1 meaning 100%. Recall has also increased to 100%, and F1 score is also 100%. So model has improved after making the imbalanced data set balance. Again, in reality, this doesn't happen. We are using actual data set, usually to get 100% accuracy is not possible. Okay, and so this data set has some problem, which I have also explained earlier, because it doesn't have that many features. Now the next algorithm that we are going to use is random forest classifier. So random forest classifier, the concept is very similar to decision tree. The random forest is a kind of ensemble algorithm. Ensemble algorithm means machine learning algorithm means it is a collection of different algorithms. So in the random forest, we have a multiple decision tree, right? And it takes the majority vote for the classification. Let's say in this figure, it has a 3 decision tree, and 2 decision tree are predicting class B, while 1 decision tree is predicting class A. Then the random forest algorithm will take majority voting, and the final class will be class B, because out of 3, 2 decision tree have predicted class B. Okay, and this is more accurate than decision tree. So if we go here, so there is the same process. First, we need to train our model on training data set. Then after training that model, we'll make prediction, and then we'll measure performance measure of that model. So here you can see the recall has actually reduced. than a decision tree. The decision tree model was actually deriving the recall of 89%, while random forest is showing only 79%. And this is okay because the decision tree has a one disadvantage of overfitting the model. So overfitting means that model will model will perform extremely well on a training data set, but at the time of actually predicting, it will fail, or the actual result will not be, the predicted result will not be equal to the actual result. So that's why we have to use different types of algorithm, machine algorithm. We cannot depend on one particular machine learning algorithm. So I think that covers both type of machine learning algorithm, right? This is just a short overview, and I also request you, those who are watching this, please explore the explore the more about this model on your own, right? And the next thing I want to show you is this visualization tool, Tableau. It is also freely available. It's a public. There is a public Tableau that you can just sign in and you can have access to this wonderful software. So in this software, what we are doing is, so let me just show you the data first. So I hope before we look at this Excel sheet, I hope you have watched, Harry Potter, right? See, this is again fictitious data. So as you can see from here, this is actually a statement of different people. Okay, so this is the statement of Lord Voldemort accomplice. So these are the account, or you can understand by this way. These are the account statement of different people who have made transaction to one another. So these are all, let's say criminals. So these are the criminal people, and who have made transfer to one another, right? And if you have to perform this kind of analysis manually, then it will be very difficult. So for that, you can use a visualization tool like Tableau. Okay. So in Tableau, you can see like what you can see that different person transferring, performing different transaction to other persons. So you can easily analyze, and from this you can also identify who is the actual beneficial owner. So let's drill down to one particular account. Let's say Lord Voldemort, right? So as you can see, he's doing lots of debit and credit account into lots of debit and credit transaction into different account, and you can also filter what type of credit account is, what type of credit transaction he is doing, or what kind of debit transaction he is doing, and further you can also on the basis, you can also do filter on the basis of amount. Like if you want to look at like higher transaction, so only if you want to just look at the higher transaction or higher transaction amount, you can also make a filter on that also. So this is a very useful tool if you have to make analysis for transaction monitoring. Okay, so you don't have to do all those analysis manually. So you can use the help of tools like Tableau. And the great feature about the Tableau is it will help. It also help in applying different types of that machine learning algorithms which we talked earlier. So in this particular example, it is using k-means clustering that we explained earlier. So it is performing clustering analysis here. So it is grouping customers, right? Different types of customer based on their similar characteristics or similar buying characteristics. So in this figure, it has identified the two group of customer. So it is very useful for the organization who want to target this category of customer. So maybe they will develop different types of marketing campaign to target this kind of customer and a separate marketing campaign for this kind of customer. And also in for AML safety personnel, the cluster analysis can also be used to identify which transactions are fraud or which are not. So this is the Tableau is very useful tool, and which I think that should be like in the arsenal of different AML safety professionals. Yeah, so this is all about the practical example, and see. So this is I think this is the final slide of my presentation. And so money laundering is now a very dynamic and a complex process. So its trends are increasing. Its new trends are coming every day. So in order to capture that complexity, we need to have a model, or we need to have a transaction monitoring system that could capture that complexity. So the transaction monitoring system can be based on different kind of model, right? And one of the model was proposed by Herbert A. Simon, right? So his model had four distinct phases. So first phases was intelligence phase. So where the decision maker will gather the information about the situation and recognize the problem at the hand. So design phase, it is identify various alternatives to solve that problem. And choice phase, where the decision maker will identify best alternative to solve that problem. And the review phase is where you look all those process, whether it was effective for the solving that problem or not. If not, then you can use that feedback for as a future reference to make a new decision. So we can use Herbert A. Simon model to create our one model for transaction monitoring. So this is so I'm talking about the machine learning algorithm. So machine learning algorithm and machine learning algorithm should be based on a certain kind of model to capture the complexity of transaction, to capture the complexity of money laundering. So this model advocates that there should be both manual and automatic. There should be both manual and automation, right? The model should facilitate both aspect. So in intelligence group, we have 4 different agents. So see, the client profile monitoring agent, it will collect the KYC of customer. It will collect the KYC and other CDD related information about that customer. And internal data collecting agent and external data collecting will collect different types of data regarding those customers. So for internal data, we can take the financial transaction of that customers, right? Financial profile of that customer. And external data will collect the information of that customer from different news sources, like let's say public sources, open data sources, regulated agencies, bodies. So, and all these information will be used by transaction monitoring agent to identify unusual transaction. And if it identifies any kind of unusual transaction, it will generate a risk report, and that will be sent to behavior diagnosis agent. So behavior diagnosis agent will take that risk report, and it will perform different kinds of machine learning algorithm to generate different kinds of alerts. Okay, so the alerts may be like the customers, like the customer is doing transaction with high risk country, or there is a large volume of transaction in the customer account which reason is not disclosed. So these alerts are usually generated by behavior diagnosis agent on the basis of the information provided by the intelligence group, right? So So after generating these alerts, it will send these alerts to reporting agent, and reporting agent will analyze those alerts and generate SAR or STR and send to the user agent. And also reporting agent can perform the function like blocking those transactions if it is like, if it could cause harm to the organization. So it can block those transactions. And so SAR and STR will be submitted to the user agent. So in the choice group, there will be a AML analyst, right? So here the model advocates that there should be a human intervention. So user will review those STR reports, and he will have all the information available to him, from transaction to the customer KYC information. So it will be very easy for that user to make the decision whether this transaction should be filed as SAR or should be completely ignored. So and this is a decision making model that are utilized by different vendors who are creating the machine learning application for transaction monitoring. So my suggestion is that if you are like looking for a vendor and who is giving you solution, or who is giving you solution regarding machine learning solution for transaction monitoring, you ask them what is the what is the model behind that solution. Okay, what is the base of the solution, how that solution perform, and if it is matches with this kind of model, then you are good to go. You can trust that vendor and implement that solution. So that's it about my presentation. I hope you have understood the most of the concept that I presented here. But if you are having confusion, if you are having confusion, or if you want to learn more about this machine learning algorithms and how it can be like applied in your transaction monitoring environment in your organization, then you can please feel free to contact me. I'll be more than happy to share my insight or opinion, and which you may find useful. So thank you for thank you for your time for watching this presentation.